In this unit, we're going to talk about the domain name system, which I touched on briefly in the previous unit. We talked about how important DNS is in any network for the network to function correctly. No one wants to memorize all these long IP addresses, especially IPv6 addresses, which we talked about. So we need a domain name system in order to have a method to find IP addresses from host names. It's sort of like the telephone book of the network, domain name system. As you can guess, the domain name system has an important role to play in the Windows Server world when we're running as a domain controller. So, a big reason that we use Windows servers is as domain controllers and for domains, and DNS plays an important role in that. So we'll talk a little bit about that in this unit as well. But it is going to be a requirement if you're running a domain controller or if you're running a Windows Active Directory domain that you have DNS servers in place, and typically that's going to be done with Windows Server. So let's get started. We're going to talk about, we're going to describe the structure of the domain name system, a little bit of how it works. Then I'm going to show you how we install and configure DNS, which is relatively simple in Windows 2012 Server. Then we're going to talk about the configuration of DNS zones, which gets a little bit more complicated. We're going to talk about some of the advanced settings that are available to us in Windows 2012. And then finally, how to monitor and troubleshoot DNS. So I divided this section into basically into 4 sections. So we'll talk about the DNS protocol and installing DNS first. Then I'll have a slide deck about configuring zones. We'll go over some of the advanced DNS settings, and then we'll have a short unit on monitoring DNS. So first, let's talk about the domain name system. So the domain name system is a distributed hierarchical database composed mainly of a computer name and IP address pairs. So the primary purpose is to marry a computer name to an IP address. So if you have a name of a service or device or FQDN, which is a fully qualified domain name, which is an important part of DNS, you should be able to use a DNS server to look up the IP address that corresponds with that. And that IP address can be IPv6 or IPv4. It's distributed, which means there is no single database. Sounds somewhat familiar because we talk about how Active Directory is a distributed database. DNS is a distributed database in the same way. Even the DNS on the internet that we all use in order to look up IP addresses from host names on the internet is a distributed database. There are many root servers on the internet, and it's distributed in the sense that when you make an update to one, they propagate those updates to other root DNS servers. As you can imagine, this makes the protocol ripe for attack for various reasons, and it is sometimes difficult to secure DNS, but we'll talk just a little bit about that. Although some of those topics are a little out of scope of this course. We normally, when we talk about DNS in Windows 2012 Server, we're talking about DNS for inside our organization or for sending updates about our organization to the root DNS servers. So in order to resolve a name to an address, the DNS lookup will often require multiple queries to a hierarchy of DNS servers. In other words, there'll be, you'll have to go through a tree of DNS servers, similar to the trees that we talk about for Active Directory. So DNS can be described as an inverted tree structure. Again, just like we talked about with Active Directory, the entire DNS tree is called the DNS namespace, and each domain has one or more servers that are authoritative for that domain. Root servers are the database of addresses or other DNS servers managing top-level domains. So top-level domains are things like .com, .org, and so forth and so on, which you're probably familiar with. So this is roughly the structure, the hierarchical structure that you would see in DNS. You can see here we have the root at the very top, and then we have a couple top-level domains, .com, .edu, .net, and so forth. And then within .com, we have second-level domains like Microsoft and Google and so forth. And within Microsoft, you have MSDN, TechNet, Downloads, and so forth and so on, which is managed by Microsoft. So if I'm inside Microsoft and I'm doing a search for TechNet, Microsoft is the source of truth for the information about how to get to TechNet. Even if I'm outside Microsoft, Microsoft is propagating those updates to all the way up through to the root server. So if I'm on some other DNS tree, I have to get back all the way up to whoever has the latest information about a subdomain within Microsoft. So again, it is a hierarchical structure, the domain name system. So the domain name system, or DNS, uses a database, and we talk about zones. So a zone is a grouping of DNS information that presents one or more domains and possibly subdomains. So zones contain a variety of record types called resource records, which contain information about network resources. And they can be changed, added, edited by through static updates, where an administrator enters the DNS records manually in the domain name server, or the DNS server. And they can also be done dynamically, referred to as dynamic DNS or DDNS. So that means that the DNS updates are happening externally and automatically through the protocol. And again, that's one of the things that's a little bit difficult sometimes to secure, because we have to have some inherent level of trust, but at the same time, we also don't allow just anyone to poison DNS. So if you take an IT security class, there'll probably be some discussion about topics like poisoning DNS, which is surprisingly easy to do. So as far as how DNS works, so there's a lookup process. There's basically two types of DNS lookups. There's an iterative query, which is where the DNS server will respond with the best information it has to satisfy the query, or it may give a referral response saying, I don't know the answer to your question, so go to this other server to find the information. A recursive query, on the other hand, is a DNS server that processes the query until it responds with an address that satisfies the query or with an I don't know message. So this is where in a recursive query, the server is checking higher up in the hierarchy until it can find the answer to your question. So a typical DNS lookup is made by a DNS client, can involve both recursive and iterative queries. DNS clients are going to maintain a text file in Windows servers. So in Windows, they maintain a text file that's stored in system root, system32, drivers, etc. directory. So you'll find in there some files that have some information about DNS, which we're going to talk about later. I'm sure some of you have probably used the host file that's in that directory. By the way, system root would be C:\Windows on most systems, although it doesn't have to be. It could have another, another name. It's just an environment variable. But within that, you'll have a system32, drivers, and an etc. And then in there, you'll find some files for DNS. And like I said, your host file, which is for static DNS, can be found there. We've actually talked about that previously in this course when we looked at some of the IPv6 protocol or tunneling protocols. Some of them use the host file. You have to put a manual entry in the host file. All right, so this is the roughly what the process looks like if you're trying to do a DNS query. So here we have a DNS client who first sends a recursive query to Microsoft.com. Maybe we're trying to get to Microsoft.com. An iterative query is sent to the root server, and the root server sends a referral to try a different TLD server. So then the fourth step is we do an iterative query to the TLD server, who sends a referral to someone else back to Microsoft. So then we query Microsoft, who then sends us back the correct address, and then that's delivered back to the DNS client. So you can see here that Microsoft.com is the source of truth for the information about a subdomain within Microsoft. And when we try to look up Microsoft's information, the root server refers us to the TLD server, which then refers us directly to Microsoft to get that information. So some of the roles with a DNS server. DNS servers can perform one or more of the following roles for a zone. So for a given zone, a DNS server can be an authoritative server, which holds the complete copy of the zone's resource records, in other words, the database about DNS. It could be a forwarder, which is a DNS server that to which other DNS servers send requests so that they can't resolve themselves. And then you have a conditional forwarder, which is a DNS server to which other DNS servers send requests targeted for a specific domain. For example, in the previous slide, you saw that we have a forwarder that was sending information about Microsoft to Microsoft. It was a conditional forwarder. And then a caching-only server, which does not have any zones. Its only job is to basically proxy DNS. So it accepts DNS queries. It goes out to a parent DNS server to get the answer to the queries, and then it caches it on the local server. And it does that so that it doesn't have to keep doing recursive lookups in the future in order to find results. And this is what most people implement in most corporate networks. They're going to implement some kind of caching-only server unless they have a domain and a domain controller and so forth. Typically, a full DNS server isn't really needed unless we have a lot of public-facing services or we're using an Active Directory domain controller. So as far as installing and configuring DNS, so a correctly configured and efficiently functioning DNS server is essential for a well-functioning network, because most of the things on your network are going to be referred to by name, not by IP address. And this is one of the things that kind of separates an enterprise network from sort of the an early network. Is in an enterprise network, we should be relying on DNS to manage these names on our network, as opposed to just having either host files or relying on things like NetBIOS to do lookups, or even not just IP addresses. So when a domain controller replicates with one another and trusts are created between domains in different forests, you're required to have DNS for that to work. So if you are going to run Active Directory in domain controllers, you have to have DNS in order to do that. And luckily, a Windows Server comes with a DNS server that has all of the appropriate functionality that we need for Active Directory. So to install DNS, it begins by installing the DNS server role within the Server Manager or PowerShell. You probably remember this from when we installed Active Directory, because this is a prerequisite to installing Active Directory. You have to have a DNS server somewhere on your network in order to run Active Directory, which we just learned why. So the DNS server is intended to manage domain name services for Active Directory. Then the DNS server role should be installed on a domain controller. In other words, if you are going to be using DNS within a domain, then DNS server should be installed, or has to be installed, on a domain controller. You won't be able to run this on a standalone server or a server that is simply a member of the domain. It has to be an actual domain controller. Windows automatically detects whether or not the server is configured as a domain controller and then integrates the DNS zones with Active Directory. There are some special things that we have to have with DNS. So if you run DNS in Windows without a domain controller, it works fairly well. It's a decent DNS server, but it is not integrated with Active Directory. There are some extra functionalities that we need with DNS when we're running it with Active Directory. So it is important that if you are using Active Directory to ensure that the DNS server is installed on an Active Directory server. All right, so in the next slide deck, I'm going to talk in more detail about creating DNS zones. DNS zones can be rather complicated, but we'll try to keep this as simple as possible. So that'll be the next slide deck.